Shall we go for zero option? Any reason for that? Because where this current carrying wire is there, outside this amperian loop, therefore what should be the net B bar dot dl for this circle? Should be zero, no? So I'll pick up this option straight away. Any reason for that? The amperian loop 20.50, what is the explanation I should give? Amperian loop or path. Amperian loop doesn't encloses any current element. There's no current element in the amperian path. There's a reason for this one. And now come for 20.51. Consider 2 points A comma B. On the given circle, the path integral of the total magnetic field B along the perimeter of the given circle from A to B. So A comma B, I think it should be, A should be here. This should be A and this should be B. So let me introduce. I'll minimize diagram. Okay, this is this circle. Huh? Let this be the y-axis, x-axis. So this is the center of the loop. A comma A will be here, and B will be here. It's asking the line integral of A bar comma, so from A to B. So where is the DL? DL you are going to take it here. That's what in the diagram he has given. Now where is the current carrying wire? That is here. How to calculate somewhere at that particular thing? So we'll do one thing, we'll go for a loop. This is something like an amperian loop. The red color is what? The amperian loop. I'm going to assume it. Huh? Let me assume here. So what is being asked for A, B only. For how the lines of force due to this will be. How the lines of force. Concentric circles I should draw, no? Draw concentric circles. So is it, shall I say, B bar parallel to DL? So problem will become very simple, no? Is it really B bar parallel to DL? No, B bar is not parallel to DL at all points. So here the B bar direction will be, you drop a perpendicular here. The B bar will come somewhere here in this direction. And at different points, what happened to the direction of B bar will be different. So only for path, this is A, B. At different points, the value of, this is DL, no? So B bar will be somewhere here. At this particular point, magnitude also will be different, direction also will be different, the angle made by it. So this will be B3. Are you able to get this? I think there's a big headache, no? What is the biggest problem? LHS, what be LHS? B1 DL cos theta 1, B2 DL cos theta 2, B3 DL cos theta 3. We can't solve, no? But still he's asking and he has given options also there. So how to bring that one? So for path OA, check it. Look at the DL. So for path path OA, what should be the value of B bar dot DL? Should be 0, no? Any reason for that? How B bar will be? B bar here will be in this direction. What about B bar? B bar will be somewhere like this. I can I find it for OB, BO? Yes, we can find out. For OA, it is 0. For AB, you can't find out. For BO, we can find out. Able to make it out? This, and here for path, what is value of B bar dot DL? For OA, it will be 0. Now for total path OAB, what should be the value of B bar dot DL? For total OAB, it should be 0. And what it should be equal to? OA B bar dot DL, AB B bar dot DL, then BO. This should be 0, no? Why 0? I'm highlighting it. Why it should be 0? Because net current enclosed is 0. No current is enclosed by it. No current enclosed by loop OAB. I'm giving enough of explanation. Now come for this. Integral OA, this, what is the problem here is, B is non-zero, DL is non-zero, but what is the thing? Angle is 90 degree. And this we cannot find, this is unknown thing which we cannot find out. Okay, let's see what are the options left over for us. So this should be 0 equal to 0 finally. So this is unknown thing which has to be determined. Unknown. How to find out for this? B bar dot DL for BO, can we calculate? It's some sort of straight line, no? The straight line. So I'll bring the logic here now. So again, I'll go back to the basics of Ampere circuit law. Nothing big. I'll stick on to the basics of Ampere circuit law. So what are the basics of Ampere circuit law? I'll come back to the problem. Suppose say if this is the current carrying wire and this is the amperian loop. I'll ask you a few questions. Where is that dot? So this is the current carrying wire I, which is present. It's a square loop. What is it for total loop? How much it is? 1, 2, sorry, 1, 2, 3, 4. All of you, please here, rather than some mathematics, just analyze logically. This is a wire, long wire. And what is the value of for total loop? Mu naught I, because what is the net current enclosed? This is a loop, no? What is the net current enclosed? High, so mu naught I. For only 1, 2, how much? Value of B bar dot DL. Don't put closed path. Now you have to be very careful. I should not put circle here. I'm just moving from 1 to 2. If I go like this, 1, 2, 3, 4, 1, closed path. Okay, that's for this circle. Able to get this closed integral. This is an open integral. This is like a line integral. This is a closed contour line integral. So what should be the value of this? So I'll just say that it is 1/4 of will I agree? Add up the total again. What is the total? 1 to 2 b bar dot dl, 2 to 3 b bar dot dl, like this we add up now, and all they are equal. So what is one more conclusion? Integral of 1 to 2 b bar dot dl, this should be equal to 2 to 3 b bar dot dl. Definitely you can expect best questions, logical thinking questions will be available for you. So is it okay, justified no total, and the sum of that, the total b bar dot dl for the loop should be sum of b bar dot dl for individual sides. And now instead of this, let it be 1/4, only 1/4. No, I will take next situation. Let me take a next situation. I'm going to bring it is at a distance of L by 2 and this is L by 2. How much for this particular thing? So what it is now, only a part of a wire, no? So here I'll bring it 1 2. So let me write 5 here. Only for 5 to how much it is?
1 by 8 mu naught I by 4. 1 by 8 into mu naught I by 4.
Mu naught I by 8.
8 by
Like this, you can bring it 8 parts, no?
Sir,
Ah.
sir, it is L comma L by 2, no, sir, in this question. L and L by 2, it should be no, sir. Because radius is 1 and it is at a distance 2.
No, only 2 5. What should be the
mu naught I by 8.
okay? That one I don't know why you are bringing other mathematics here. W 1 by 8. I think it's not appearing circle, square. So just logical thinking. For leave all your geometry. Leave all your geometry. Keep your geometry aside. Just focus on what is that 2 5. It's the midpoint, no? 5 is the midpoint of 2 1. So what should be the length? Now I'm constructing the total loop. Please do understand that this is very important. It will help us a lot in solving many of the numericals. Yeah, I'm completing the loop. Oh. Yeah. I'll indicate all the points, at least. Please, all of you, understand this. This concept is very important. This concept is very important. So this is L by 2. This is L by 2. This is L. So how much, what is the value of b bar dot dl for 2 to 5 to 2? Should be mu naught I by 8. 1/8 of the loop linking. Okay, this one. So there's a long wire again. Now come for this. So can we use this there to solve the above problem. This idea, can we use that one as it's similar, no? Can we make that OB is a part of a loop, construct a loop, and think that how much it is going to link it? OB only, AB we can't find out. And what is again the requirement? So if you look at the, I'll come back to the problem. Hope everyone understood the logic which we wanted to generate there. Now let's focus on the numerical now. Can we calculate OB or BO? But sir, like we don't know. So do we know distance O? It is 2, 0, no? And what about this? 2, 1, 0. I think that's what the limits they are given. You see this. And radius 1 meter. So the limit for this will be, now take help of this. So construct now a loop. So how much of total generated will link that one. So here I have to go for so let me draw a circle. For that circle, this theta is what? If I draw a circle, mu naught I by 2 pi will be the total thing which will be linking, no? Mu naught I by 2 pi for full circle. Then for angular displacement theta, how much it will be?
mu naught I by 2 pi into theta by 2 pi.
So shall we take up the same basic logical thing? For 2 pi angle, so theta by 2 pi, I should write mu naught I theta by 2 pi. So the value of this, I'll write it here only. BO integral of B bar dot DL should be equal to mu naught I. And now what is the mu naught? I'm directly writing it rather than you complete the circle, then how much it will be? You complete circle like this. How much it should be? It should be equal to 2 pi. So for only for this much of angle, how much it should be? Theta by 2 pi. So we don't know theta. Theta, I think we can calculate. No? Tan theta is how much? Tan theta is 1 by 2. Substitute that here. So B2O mu naught I tan inverse of 1 by 2. But our thing is we have to calculate AB, no? So according to this formula, so what you can write it here, integral of A to B, B bar dot DL is equal to minus of B to O, B bar dot DL. So negative of that, it should be this one. Okay, only magnitude. We can, so this is the value of this one. After this one more, the maximum value of path integral B bar DL on the total magnitude will be along the perimeter of the given circle between any 2 points on the circle.
Sir, for B2O, you should write minus sign there because the angle between B bar and DL bar is 180 degrees. The limits are from B2O.
Okay, okay, B2O. Okay, here only I'll bring that negative sign. Huh? That'll be okay. Yeah. No, the maximum value of path integral B bar DL of the total magnitude will be along the perimeter of the given circle between any 2 points on circle. Means something is asking you take out anything. So where the value of B bar dot DL will be maximum. When it will be maximum? when it will be maximum. So value of b bar dot dl of the, I think you have to read question, along the perimeter of the given circle between any 2 points on the circle. What is the meaning of this? What you mean to say is, I think I have space above. I'll do this problem here. This is the thing. This is the x-axis, y-axis. So let me draw a tangent then it will be maximum, no? The value of b bar dot dl from point P1, I'll move to P2, will be maximum if I move from P1 to P2. The meaning of question, what is said, the maximum value of path integral of b bar dot dl of the total length will be along the perimeter of the given circle between any 2 points on the circle. So where is the path? Now there's a path. So there's a path which I'm going to take here now. So when it will be maximum? When the P1, P2, so the line joining from the Y to P1, P2 should be tangent to the circle. There's a circle. This what, no? How much it will link here? Theta by 2 pi. How much it will link? So that will be 1 by 8 of that one. Okay, so this theta only in terms of theta by 2 pi, I should bring it here. Of the total it will link, it should be called theta by 2 pi. Okay, now work out this. This will be maximum. So when do this, how much this, anybody, angle? So when it will be maximum is telling that one. So check for this. I'll give answer, verify this one. Yeah, 60 degrees. Again, use the same formula, theta by 2 pi. Okay, let's go for now. Few more ideas you needed for your help. Let's go